So this is an explanation of experiment 17, gas laws, and specifically what we're doing is determining experimentally the value of R, the gas constant. So this is the setup. What you're going to do is have a round bottom flask in the middle, Erlenmeyer flask on one side and beaker on the other. In the round bottom flask, you're going to have a 2-hole rubber stopper, and in that 2-hole rubber stopper, you're going to have a piece of long straight glass tubing and a piece of short bent glass tubing. When you put the glass tubing in the rubber stoppers in this experiment, please be really careful. It's really easy for it to break and to cut your hand, so use plenty of glycerol and just be careful. Over here, you're going to have an Erlenmeyer flask. There's going to be a 1-hole rubber stopper, and in that 1-hole rubber stopper, you're going to put a piece of short bent glass tubing. You connect the piece of short bent glass tubing in the round bottom flask to the piece of short bent glass tubing in the Erlenmeyer flask. If you connect the wrong piece of glass tubing in the round bottom flask to the Erlenmeyer flask, the experiment will not work. Make sure you connect the short bent to the short bent. Once you get the glass tubing and the rubber stopper set up, you're going to fill the middle round bottom flask all the way with water. So take the rubber stopper out, fill it to overflowing with water, put the rubber stopper back in. Then what you're going to do, okay, by the way, connect the tubings, the glass tubing with the rubber tubing from your lockers. In the lab book, it has a piece of glass tubing at the end of this piece of rubber tubing. You can put one there if you want to. It's just to hold it down. I've never needed it. So once you have the round bottom flask full of water, you're going to take the rubber stopper in the Erlenmeyer flask out. Use one of those blue rubber bulbs and push the air through the glass tubing, through the rubber tubing, through this piece of glass tubing. And what's going to happen is when the air gets pushed through here, it's going to push the water in the round bottom flask up through the long piece of straight glass tubing, through the rubber tubing, and over into the beaker. Once you see water starting to come out of the piece of rubber tubing here, you can clamp this piece of rubber tubing off up here somewhere with your pinch clamp. Okay. Now what you're going to do is with this still clamped off, you're going to remove the rubber stopper in the round bottom flask, pour the water that went over into the beaker back into the round bottom flask, put the rubber stopper back in, you're ready to go. Clamp's still there. Next, okay, you will have previously weighed out about 0.9 grams of zinc. Remember, 3 places past the decimal. Take the zinc, remove this rubber stopper, drop the zinc in, immediately put the rubber stopper back in, and at the same time, remove the clamp that's over here. What will happen is the zinc will react with hydrochloric acid. Oh, I forgot to mention you have 25 milliliters of 6 molar hydrochloric acid in here. Use your graduated cylinder to measure out the hydrochloric acid. The hydrochloric acid, it's on those red trays on your lab benches. So the zinc will react with the hydrochloric acid, producing hydrogen gas, which will move up through this piece of glass tubing, through the rubber tubing, into this piece of glass tubing, and it will push the water up through the piece of long glass tubing. Water will come up here and collect over in this beaker here. The reaction goes pretty quickly, shouldn't take long. You'll know it's done because all the zinc will be gone, the water will stop moving, and you won't see any of the hydrogen gas being given off. Once that happens, before you clamp this off again, what you're going to do is you're going to raise this round bottom flask up until the level of the water in the flask matches the level of the water in the beaker. Don't expect the water to move back and forth through the rubber tubing. You're just making the level, you're just matching the levels. The reason is when you do that, that makes the pressure above both of them the same. So at that point, clamp off this piece of rubber tubing, and you're done with everything from here over. What you need to do now is first measure the temperature of the water in the beaker. Remember, 1 place past the decimal. Once you've measured the temperature of the water in the beaker, take it over to the hoods. There will be a few large graduated cylinders in there. Dump the water into the graduated cylinder and write down the volume. We're assuming that the volume of water that gets pushed over and that you measure in the beaker is equal to the volume of the gas that pushed it over, that was produced in the reaction. All right, so now what we're going to do is talk about the calculations. So, calculations. Okay. First thing is you need to put the table of vapor pressures that's on page 210 in your lab manual into your constant section. In the constant section, you also need the accepted value of R, 0.08206 liters atmospheres per Kelvin mole is what we use. So you're using the ideal gas law, PV equals nRT, and you're finding R experimentally because we're measuring PV, N, and T. For the pressure of the gas, what you need to do, I'm going to give you the atmospheric pressure, but that's not the pressure that you use in this equation. What you're going to do is you're going to subtract out the vapor pressure of water at the temperature of your gas, which we assume is the same as the temperature of the water in the beaker that you measured. You look that up in the table on page 210, or that you have in your constant section. Subtract it from the atmospheric pressure that I give you. That difference is the pressure that you use here. That's going to be in millimeters of mercury, so what you're going to have to do is convert that to atmospheres by dividing by 760. The volume, the V in this equation, it's the volume of gas in liters, and we're assuming that's equal to the volume of water that's displaced. You measure this in the graduated cylinder in the hood. N, the moles of gas, because the mole-to-mole ratio in the balanced equation is 1:1 between zinc and hydrogen, we're assuming that however many moles of zinc you weighed out, that's how many moles of gas you produced. So to get the moles of zinc, just take the mass that you weighed out in grams, divide by the molar mass of zinc, about 65.41 grams per mole. The temperature of the gas, again, that's the temperature of the water, we're assuming. You're going to measure it in Celsius, one place past the decimal, convert it to Kelvin by adding 273.15 to it. And plug in, get R. Then the last thing you're going to do is you're going to calculate the percent error, which is going to be the absolute value of your value that you got, experimental value of R, minus the accepted value, which is 0.08206. The absolute value of that difference divided by the accepted value, 0.08206, then times 100. And then you're done.